In the present day, there are a lot of technologies related to the field of brain-computer interface. When we thoroughly analyze these technologies, we can see that they are either expensive or complex enough to develop. So, we are utilizing this opportunity given by Texas Instruments Private Limited to develop a low-cost application-based EEG equipment. We can use EEG for different kinds of BCI applications such as medical analysis, brain control prosthetic limb, learning disability detection, controlling hardware, and brain control gaming.
HAYA or How Active You Are is a single channel EEG equipment with an embedded microprocessor. HAYA is basically a multi-application process. It monitors the brain wave using electrodes placed on the forehead and effectively calculates the theta, which ranges from 4 to 8 Hz, alpha 8 to 12 Hz, and beta 12 to 18 Hz frequency range. According to the research of Joel Luba, the power ratio of beta 1 to theta and alpha to theta can be used to monitor the concentration of human brain. So, HAYA calculates beta 1 to the theta and alpha to theta ratio and monitors the concentration of human brain. It means when beta to theta ratio goes higher, it resembles higher level concentration. When medicating or in a relaxed state, alpha waves will be generated in brain. So, we will get a comparatively higher deflection in alpha to the theta ratio. Theta waves basically represents immaturity of human brain. In infants, theta waves will be dominating other frequency ranges. As they grow, alpha and beta waves starting dominating the theta.
This is the block diagram of HAYA. It consists of two units. The first unit is the amplifier unit and the other is the processing unit. The input consists of 3 electrodes. The first 2 electrode is connected to the instrumentation amplifier with a high voltage protection circuit and a gain of 12.36. Then the third electrode is the reference electrode. It is also connected to the instrumentation amplifier. The signal from the instrumentation amplifier is given to the high-pass filter with a cutoff frequency of 0.4 Hz. So it allows the frequency range of 0.4 and above. Then the signal from the high-pass filter is given to the non-inverting amplifier with a gain of 40. Then the output from the non-inverting amplifier is given to the Pachal filter with a cutoff frequency of 59 Hz. And a gain of 13. Then the signals from Pachal filter is given to the beagle-bound black, which is a processing circuit. The signal from the Pachal circuit is given to the analog input of beagle-bound black. The beagle-bound black consists of analog to digital converter and the output is given to the display.
So now we have the hardware prototype of HAYA available here. It consists of an EEG amplifier section and a EEG processing section. We have 2 EEG electrodes and a reference electrode available here. These electrodes are made up of AG and AGCL, and our electrodes are connected to the instrumentation amplifier, which we have used here is INA 114 from Texas Instruments, which provides a high CMRR of 115 dB, and our reference electrode is connected to a buffer and to the instrumentation amplifier. The output of instrumentation amplifier is connected to a high pass filter which cutoff frequency is set as 0.4 Hz, and then to a non-inverting amplifier, and then output of non-inverting amplifier is connected to a third order Pachal filter. Then the output is given to a potential divider circuit, which we control our output in a range of 1.8 volt, and it's connected to the beagle-bound black, which all the software process is happening here, and it is connected to the analog to digital converter pin 40, and we have given the voltage as well as the ground. Now we can move on to the live demonstration session of HAYA. We have the experimental setup ready to run, and we have powered up both the prototype HAYA amplifier section as well as the EEG processing section. So you can see the beagle-bound black is running, the blue light LED is blinking, and we have connected to the monitor through the HDMI port, and we have connected the EEG electrodes to FP2 and FP3 positions, and the reference electrode is connected to the right leg. Now our project is running. You can see the plotings from Beagle on black. So in the right side you can see the alpha waves are propagating. In the left side it's a filtered beta waves. So Mr. Baggieo can blink his eyes to produce a alpha wave pattern. You can see the deflection that happened in the alpha wave section.
Now our program is plotting alpha to theta ratio and beta 1 to theta ratio. Alpha to theta ratio will not always follows the same pattern of beta 1 to theta ratio because it is task related. So we can compare these two outputs to get the activity level of brain. HAYA is basically a multi-application product. It can be used to provide real-time feedback for drivers about their concentration while driving. Students can also make use of HAYA while studying. We know that no one can concentrate for a long time. But if you know how much you have concentrated for 20 minutes or so, we can improve that through practice. HAYA can also measure the depth of meditation. So it has a huge application there. By putting multiple channels of EEG amplifiers, we can use the project for extended BCE applications.